The Salish Sea Marine Survival Program funded Kintama to do a test of the technology. This was something that was needed before we can actually use these transmitters in practice and tracking the smolts. So the project that we worked on in 2015 had to do specifically with looking at how well a new small transmitter worked relative to a larger transmitter that we implant into salmon smolts. So the transmitters that we have been using for the past decade, they are a larger transmitter that transmits on 69 kilohertz. And the smaller transmitter, which transmits at 180 kilohertz, the new smaller transmitter it's just under a half a gram. So it's significantly smaller, so we can actually implant those transmitters into smaller fish. And then we have the ability to track smaller fish through the Salish Sea. So what we did was we double tagged large steelhead smolts from the Seymour River. And we used 2 acoustic transmitters in each fish, and we tagged 50 fish total. And so we put the larger, louder acoustic tag in the fish, as well as the smaller acoustic transmitter. And then we tracked those fish from their release point. What we did was we compared the larger, louder tag to the smaller, quieter tag. And we knew that that large tag would basically would give us almost perfect detection. And if we have a perfect detection rate of the louder tag and the little tag isn't detected, then we have some idea of the performance of the smaller tag. And that was the technical test that we did this year. So now, with this new tag, we can tag fish that are probably as small as 100 millimeters or 10 centimeters and track them through the ocean. And we can potentially track them for thousands of kilometers. We have an array in the Strait of Georgia. There's also receivers in Puget Sound. There's an array that goes across the northern Strait of Georgia. And as you work your way north, very far north, there's an array that goes across Queen Charlotte Strait. Now in 2015, thanks to the Salish Sea Marine Survival Project, we have 2 additional areas where we can detect fish, and that's across within the Discovery Islands, which is north of the Strait of Georgia, and also up in Johnstone Strait. So there's this area where all the fish are constricted, and they have to go through Johnstone Strait if they head north, and there's an array there to detect fish as well. So we have a number of places where we can detect fish, so we've got the Salish Sea covered. We have to consider a number of things. We have to consider the depth and the currents and the spacing between the receivers. So we have to take all of this into account. We also have to think about the biology of the animal. How fast will the fish be moving past? So how many times will it be within that detection zone around a receiver? So we have to think very carefully about the way we design acoustic arrays in order to track fish. And then deploying the gear and then keeping it in place and then recovering it, that's a huge accomplishment. This could be a big leap forward, yes, particularly for salmon research in the Pacific Northwest.